For the imine hydrolysis, to predict the product, just find the carbon that is double bonded to the nitrogen, and in the product that will end up being the carbonyl. So the bond it's going to break is the carbon-nitrogen double bond. So the bond that the carbon that I highlighted in blue, that will become the double bond O, plus the nitrogen ends up adding 2 hydrogen. So you end up with the amine. So there's your hydrolysis products. Sometimes you will see the nitrogen drawn in the protonated form depending on how much acid is used. You can protonate that. I'm not going to be real picky on whether you draw the protonated or neutral nitrogen. All right, let's go through the mechanism. We're going to start with the imine. And we'll protonate it. And this is the exact same imine that we formed in our discussion of the reaction of aldehydes and ketones with primary amines. So, I would encourage you when we're done here to look back at that mechanism and see how all of the intermediates are identical, just written in a reverse order. Okay, so the first thing that happens is we're going to protonate the nitrogen. Next, water will get involved. I'll use a lone pair on the oxygen to add that to this carbon. So we have OH2 plus. And the amine. From here, let's just take the shortcut and do the proton transfer within the molecule. So I'm going to transfer the proton from the oxygen onto the nitrogen. Okay, now I have the protonated nitrogen, which, having a positive charge, is a pretty good leaving group. So the next thing that will happen is a lone pair on this oxygen will assist. It will push down to form the double bond between the carbon and oxygen, and the nitrogen will depart as a leaving group. So we get the protonated oxygen plus methylamine. And then finally, you can use a B with the lone pair, you could use water, you could use this amine that you lost, just something with a lone pair will come in and take that proton off of the oxygen. So that's how we end up with the carbonyl and the amine.